Dear students, welcome to the video expressing a sine of theta plus b cosine of theta in the form of r sine of theta plus minus alpha or r cosine of theta plus minus alpha. In this section of this chapter, we are going to learn how to solve equations of the form a sine of theta plus or minus b cosine of theta is equal to a constant like c. So when you have such equations, you see that there are two trigonometric equations used in this equation. Both sine and cosine are seen here. So none of the methods that we have learned will work here. So we need to convert this equation to the form that you see just one basic ratio, sine, cosine, or tan. Here it is impossible now to directly solve this equation. So that's why we learn actually to rewrite or to replace such expressions by r sine of theta plus minus alpha, or when you have a cosine of theta plus minus b sine of theta, it can be written as r cosine of theta minus plus alpha, where r is square root of a squared plus b squared, and alpha is an angle, so that tan of alpha is equal to b over a, and alpha is between 0 and 90 degree. There is no need to memorize this formula for those students who are studying in Cambridge system, as in Cambridge questions you will see that they will give you the form that you are going to use in order to replace such expressions. So using compound angle formula and expand them and comparing coefficients, you can easily find a and b and r and alpha. A and b will be given in the question, so you are supposed to find r. These are the parameters should be found, one r and one alpha, to replace these two expressions when you see in your trigonometric equations. Now let's see some examples. First example for this part, express 2 sine of theta minus 3 cosine of theta in the form of, as you see, it says right in the form of r sine of theta minus alpha, where r greater than 0 and alpha lies between 0 degree and 90 degree. Give the value of alpha correct to two decimal places. And part B, hence is a command word. Note that when you see hence, part A's answer must be implemented in the second part. Solve the equation 2 sine of theta minus 3 cosine of theta is equal to root 2. Theta is between 0 degree and 360 degree. Now, so 2 for part A, 2 sine of theta minus 3 cosine of theta is supposed to be written in the form of r sine of theta minus alpha. So I write the left hand side, sine of theta minus 3 cosine of theta is equivalent to, we know expansion of sine of theta minus alpha, it will be sine of theta cosine of alpha minus cosine of theta sine of alpha. Now again I write the left hand side expression 2 sine theta minus 3 cosine theta. Now I multiply both by r, it will be r. I write first cosine of alpha, then sine of theta, because it will be easier to compare left hand side and right hand side, minus r. Now I write sine of alpha cosine of theta. Now to equate these two expressions, they should have the same terms and coefficients. Here on the left hand side you have sine of theta, here sine of theta, so they should have the same coefficient. So it means that 2 must be equal to r cosine of alpha. R cosine of alpha is equal to 2, and these two as well, cosine of theta, so they should have the same coefficient. So it is They both have negative, so it should be 3. I write it here. R sine of alpha must be 3. Now, in order to find alpha, you can again write them. R sine of alpha is equal to 3. R cosine of alpha is equal to 2. If I divide left and right hand side, so R and R cancel out. Sine divided by cosine will be tan. Tan of alpha will be equal to 3 over 2. If you take tan inverse of 3 over 2, you should solve the equation, find some angles, but alpha should be between 0 and 90. So the acceptable answer for alpha is 56.31 degrees, the answer for alpha. And r we already know that it is the square root of a squared plus b squared. Even if you don't remember this relation, you can replace, because you have the angle, replace in one of the formula, for example cosine of 56.31, replace it here to find r. So r will be a square root of a, which is 2 squared plus 3 squared, which is root 13. So r is found as well as r. Now we can rewrite this expression. So r is root 13, then it will be sine of theta minus alpha, which is 56.31. As I do not have enough space, I cannot write the left hand side. So this is the expression that we are looking for. For the second part, hence solve the equation. So this expression can be replaced by this expression that we just found, which is root 13 sine of theta minus alpha, which is 56.31 degrees equal to root 2. Now first I divide both sides by root 13 to get rid of this root 13. Sine of theta minus 56.31, which is a square root of 2 over 13. Now you can replace let theta minus 56.31 be, for example, x. So sine of x is a square root of 2 over 13. I first take sine inverse. So x will be sine inverse of a square root of 2 over 13. So x, which is equal to 23.09. Then next answer, we know that next x is 180 minus 23.09, which is equal to 156.91. Then 23.09 plus 360, then 23.09 minus 360, then 156.91 plus 360 and 156.91 minus 360. So this is acceptable. These are actually x. These are x's. Now so theta will be x plus 56.31. So here it will become 383.09. Here will be if you subtract 23.09 minus 360 is 336.91. Here 156.91 plus 360, which is 516.91. Then 156.91 minus 360, which is negative 203.09. Now these are the values of x. So theta is x plus 56.31. So here theta will be 23.09 plus 56.31, which is 79.4, which is acceptable. Here theta will be 156.91 plus 56.31, which is 213.22, which is acceptable. Here it will be above 360, so it doesn't lie in this interval. 336 plus 56.31 here as well, here will be negative. So we have just two acceptable answers. Theta is 79.4 and the last one 313.22. So these are the two answers in this interval. Second example for this section, express 2 cosine of theta minus sine of theta in the form of r cosine of theta plus alpha, where r is greater than 0 and alpha is between 0 degree and 90 degree. Hence, find the maximum and minimum values of the expression 2 cosine of theta minus sine of theta and the values of theta in the interval theta between 0 degree and 360 degree for which these occur. Now, again, I write the left hand side is equivalent to r expansion of cosine of theta. It will be cosine of theta cosine of alpha minus sine theta sine alpha. So it will be 2 cosine of theta minus sine of theta is I multiply by r. I first write r cosine of alpha as the coefficient, then cosine of theta minus r sine of alpha sine of theta. Now I equate coefficients. Here cosine of theta has a coefficient of 2 on the left hand side, so right must be the same. So r cosine of alpha will be 2. Here sine of theta has the coefficient of r sine of alpha. Here has the coefficient of 1 actually, so it should be 1. So r sine of alpha must be 1. If I divide left and right hand side, r and r cancel out each other, so it will be tan of alpha is equal to half. Taking tan inverse, alpha will be tan inverse of 1 over 2, giving you an answer of 26.57 degree. It is alpha. R is root of a squared plus b squared. Again, you can replace this value of alpha here in this one of these equations to find r, or you can use this formula. R is the square root of a, which is 2 squared plus 1 squared, will be root of 5. So our expression turns to be r, which is square root of 5 cosine of theta plus 26.57 degree. It says hence means that this actually the answer which is just found must be implemented. The maximum and minimum values for the expression. So let me erase the page to have more space to solve the rest of the question. Again, I write the expression that we just found. R was root 5 cosine of theta plus 26.57. Instead of finding minimum and maximum of this expression, I find maximum and minimum of this expression. Now, we know that cosine is takes values between positive 1 and minimum 1. So a maximum value will occur when this expression is 1. So maximum will be radical 5 actually. And for the minimum, so cosine will take negative 1 as the lowest possible value. So it will be minimum when it is negative 1. So positive 1 will be max and negative 1 will be mean. So it will be root 5 times negative 1, which is negative radical 5. So it is maximum and minimum value of this expression. But you're supposed to find the angle. So we need to solve two equations. Once root 5 cosine of theta plus 26.57 once is equal to root 5. So root 5 cancel out. So cosine of theta plus 26.57 will be 1. If you solve this equation by taking cosine inverse and replacing theta plus 26, I won't solve it completely. You can do it and check your answers. So final answers will be theta for this part 333.34. Here will be 4. It is for the maximum. And for the minimum, root 5 cosine of theta plus 26.57 will be equal to negative root 5. So root 5 cancel out. So cosine of theta plus 26.57 will be negative 1. Then the answer will be here for this part will be 153.4. So this angle will give you the maximum possible value, and this angle will be giving you the lowest possible value for this expression. This part is over, and thanks for watching this video.